Are we live?
Yes.
Live. Hi, welcome to the Gaithersburg Community Museum and Latitude Observatory's first virtual skywatching program. I'm Karen with the Community Museum, and until we can safely gather in Observatory Park, we will be bringing you virtual programs like this one. We're very excited to be bringing you this talk with Keri Bean from NASA's Jet Propulsion Laboratory in Pasadena, California, also known as JPL. Since this program is live, you'll have an opportunity to ask questions at the end. Just place your questions in the comments section and we'll gather them up to ask Keri later. Keri Bean is a systems engineer at JPL, but she was born in Fairfax, Virginia, so this is her home area. She currently works on the Curiosity Rover as a rover driver and on Mars Perseverance Rover as the training lead, and as a Psyche mission operations system engineer. Keri got her bachelor's and master's degrees at Texas A&M University in meteorology with a focus on the weather on Mars. Her hobbies mostly center around Star Wars, as she is an active member of the R2-D2 Builders Club with her very own astromech and cosplays with the Rebel Legion. It sounds pretty awesome. So Keri, before we begin, I have this little video I want to share with you and the audience. Denny and David Booley did this Mars Rover activity that we got from the National STEM Informal Educators Network. And it's supposed to model what it would be like to drive a rover on Mars. So Denny is the one who'll be going through the course blindfolded. He's going to be the Mars rover. And David will be giving instructions. So I guess he's really you. I have to warn the audience, the volume on this is a bit faint. So turn your volume up. Okay. Here we go.
2 steps forward. 1 step to the left. 1 step forward. 1 step to the start. And left. 1 step to the right.
I had to mute it. For those in our audience, they might know that the museum is right next to the railroad tracks, so we often get a lot of extra sound. So, of course, my question to you, Keri, is this really what it's like to drive a Mars rover? And just before you start, I want to remind people, if they have questions, to put them in the comments. So.
Yeah. Well, it's not too far off. So I'm going to switch to a little presentation I've got here to show some cool pictures we've got from Mars and a little bit about what it's like to be a Mars rover driver. So as Karen introduced me, I'm Keri Bean. I'm a systems engineer at NASA's Jet Propulsion Laboratory, and you can find me on social media as Planetary Keri. So, you know, a lot of people, when they think of Mars rover drivers, they think, well, they've got to have like a PhD in robotics or computer science and years of training, and you have to be really good at using joysticks, you know, practice with your computer games, and you have to be super lucky to end up with this, like, you know, not many people get to be Mars rover drivers. You kind of have to be in the right place at the right time. So, oh, actually, I do want to point out one thing. So what I'm holding there, that was my very first day as a trainee on learning how to drive Opportunity. And so they actually printed me a little, you know, practice driver's license, which is what I'm holding there. So to actually be a Mars rover driver, you do not need a PhD in robotics and computer science. A lot of the initial folks did have some sort of degree like that, but especially these days, not so much. So as I said, I have degrees in meteorology, looking at the sky. That has nothing to do with driving on the ground or with robots. And yet here I am driving a Mars rover. So it's a lot more about how you think than what you know. It does take years of training. I began training back in December of 2016, and I just got my official driver's license in the last few months. So it takes a long time. We don't actually use joysticks. We use just normal computers. And I'll talk a little bit more about it, but we do not operate the rovers in real time. I am not sitting here pushing a button and it occurs on Mars that instant. I'll talk a little bit more about that process in a minute. But on the last point, I still think you have to be a little bit lucky to end up being a Mars rover driver. So yeah, so you don't need a robotics PhD. One of the guys who basically invented how to drive a Mars rover has a Bachelor of Fine Arts in sculpture. Another one was a dual computer science and English major. I have degrees in meteorology. We've also had some with degrees in geology and other things. So as I said, it's a lot more about how you think than what you know. There is no Mars rover major at any university, so you have to be able to learn on the job. So we don't use joysticks. We actually plan 1 to 3 days of rover activities at a time. So we start out with activity planning. This is where all the scientists come in and say, you know, they look at the data that came down from Mars and they say, all right, well, what are we going to do? So let's take a picture of this rock. Let's drive to that rock. Let's, you know, use the laser on this one, whatever kind of experiments that they want to do for the day. And so then we make this whole plan and we bundle it together and we send it via the Deep Space Network to our rovers on Mars when they wake up in the morning. And while they're working, at the end of their day, they'll send back the data to one of the orbiters around Mars, and those orbiters will send the data back here to Earth through the Deep Space Network again. So all of that data comes down on the ground, and then the next morning, the scientists and engineers wake up, look at what happened, what we planned to do. Maybe we didn't quite drive to the rock that we thought we were going to make it, or something like that. So then we can then plan the next day of activities. So Mars Day is about 40 minutes longer than an Earth Day. And so at the very early beginning of every mission, for the first couple months, everyone lives on Mars time. So one day your shift starts at 8 a.m., the next day 8:40 a.m., the next day at 9:20 a.m., and all the way around the clock. I've done Mars time twice now through Phoenix and Curiosity, and it's quite an experience. You're kind of trapped with all these other people living on a different planet. You know, you have to put blackout curtains up on your windows and all that kind of stuff so you can actually sleep during the day. But engineers and, you know, scientists and all the other people that work on the mission would not be very happy living on Mars time for years and years and years and years. You'd be out of sync with everyone on Earth, right? So we'll go in and out of what we call nominal and restricted mode. So restricted is when the Mars Day and Earth Day occur at the same time. So we always plan at least 2 days. So we'll get the first days of activities back, where the second days, there'll be activities that won't influence what we want to do. Maybe it's just taking pictures or something like that, but we'll only do a drive on like the first day because we want to see our new spot where we ended up so we can plan the next set of activities. We're nominal when the Earth Day and Mars night line up. So basically the rover goes to sleep, we plan all the activities, and when we're going to sleep, that's when the rover is waking up and we send our plan. So we'll shift our time a little bit. You know, we'll start as early as 6 a.m. and start as late as noon, but most of the time it's 8 a.m., just kind of a normal workday schedule. So it does take a long time to train to be a Mars rover driver. You have to learn how to analyze telemetry. This is all the data coming back from the rover saying, I drove over this kind of rock and I had this suspension angle, and you know, how do you analyze what actually happened versus what you plan to happen? There's a whole bunch of different ways that we can drive the rover. There's all sorts of safety checks that we have to do with the rover, and we can control a lot of the parameters with them. So how do you learn what's safe to change, what's not safe to change, what kind of terrain you're okay with changing them on, all that kind of stuff. What kind of rocks are safe to drive over? And all of that usually takes it about a year or two to really learn how to get that intuition. So I listed there our class schedule. So we start out with mobility basics. What kind of suspension system does the Rover have? What is the wheel size? All that kind of stuff. Terrain basics. What are the different types of terrains that you're going to encounter? What are the different rock types that you're going to encounter? The simulated environment. Now that we've taken all these pictures, we turn them into a 3D mesh environment so the Rover drivers can actually look around and see what the safest path is. Then you learn how to drive, what the actual commands are through sequencing. And then there's some uncertainty. Maybe the Rover will slip a little bit. Maybe it doesn't quite know exactly where it is. You have to learn about all these different ways that the Rovers thinks it may know where it is, but it's not. And then there's visual odometry, which I'll show an animation of to better explain. But it's basically a way to track your position. And then there's some rare stuff, maybe recovering from a rock that we drove over that we didn't intend to drive over, so the wheel stuck up in the air or something like that. How would you recover from that? The next one is downlink and strategic. So looking at all that information coming back, and also strategic. So there's the day-to-day planning, but we're also planning what the rover is going to do over the next few days, just as a general idea of like, okay, if we're going to drive here, we want to continue driving onto here and continue driving onto here. How are we going to do that? And then your first shift. And this is basically preparing you for actually going in and sitting down on the job, on console. What are you going to do? So the main software suite that we use is called RSVP. So it basically helps you visualize your surroundings, including using these 3D glasses, this red and blue glasses. Normally when we're at JPL, we have a much fancier set of glasses, but now that we're home and we don't have all the really high-end desktops that we would normally have, we've switched back to using red and blue glasses while working remote. So yes, this is actually the very chair in which I sit and drive the Mars Rover every day. So this software suite has been used for almost every Mars rover at this point, and also will be on Perseverance, which is launching next week. So we have a couple different ways to drive the rover. So there's a way called blind driving, where the rover is not really keeping track of its position. It's just relying on how far the wheels have spun to really give you an idea of where the rover is. And we'll use this on terrain that we consider very benign. So you can look at that picture. There's not really any rocks, hazards, no sand dunes we can get stuck in, anything like that. So we would feel very comfortable just telling the rover, just drive. If we think we might experience some slip, maybe we're going to go through a little sandy patch or we're at a high tilt, we'll use visual odometry, which actually takes pictures and measures the difference in where the features are between the pictures. And that will actually tell you, maybe the rover thought it drove a meter, but it actually slipped. And so it only drove maybe 80 centimeters instead. And so it will actually take that into account and plan its next drive step, taking that into account and driving a little extra. And then on the furthest part there, the little animation that's going, we actually have a way of doing onboard hazard detection and avoidance. So maybe we can't see all the way to where we want to go. We can actually tell the rover to go ahead and continue on to that spot. And it can figure out whether it feels safe to proceed or not. So we kind of have a lot of little tweaks. We can be either very precise or we can just be like, meh, you figure it out, you go. So the official job title is not Rover Driver, it's actually Rover Planner, and we actually operate the robotic arm as well. So that's another reason it takes so long to train, because not only you're learning how to drive, you're actually learning how to use all the instruments at the end of the robotic arm to do science. So these are some of the things that I've gotten to do on Mars with the robotic arm. So the black and white photo is showing us preparing to drill at a drill site a couple months ago. And so this, we didn't actually drill yet. This was basically us pushing it into the ground and seeing if the rock like moved or anything before we actually start drilling. And then we actually have a brush on the end of the arm as well. And so the color photo is actually showing where I brushed away a little bit of dust, and you can actually see the rock is a little bit more gray instead of the normal kind of brown of Mars. Another fun thing we get to do with a robotic arm is actually take selfies. So very recently we took a selfie and we actually took a camera photo of the robotic arm performing this selfie, because that's like one of our #1 questions is how do you take the selfie? The answer is not aliens, it's with a robotic arm. You know, normally you don't see the arm, but if you think about it, when you're taking a selfie, you don't really see your arm in your selfie anyway. So that's really what's happening. And so I think it's just a really cool little animation that shows how we take our selfie. So Curiosity gets selfies all the time. The Opportunity rover, we only took one selfie not too long before it died, unfortunately. And it did not have a nice color camera on the end of its robotic arm. It was only black and white, and it was not anywhere near as high resolution. So that's why it's this kind of small black and white photo, but it was still really cool to see the rover on Mars. So here's a lesson on what not to do. Do not let your coworkers pressure you into coming in on your day off to brush off some dust on Mars, which eventually causes a global dust storm that kills the rover you're working on. So everyone at work teases me for being the reason that Opportunity unfortunately passed a couple years ago. So I was still learning how to be a rover driver and on Opportunity. And so my one and only day that I actually got to go in and write the commands was actually to put the robotic arm down on the ground and brush. And within 2 weeks, we lost contact. So everyone blames me. Oh well. So on Curiosity, my personal odometry so far is 655.69 meters. This is another one of my favorite photos from one of my drives. So we approached a little sand ripple and we actually used the rover to basically dig a little trench so the scientists could actually see what the property of the dirt was below the surface. So I think that was really cool. I kind of got to scuff on Mars. So I'll talk a little bit about Perseverance since that's coming up. So please tune in to NASA TV next Friday, July 30th at 7:50 a.m. Eastern to watch our newest Mars rover, Perseverance, which actually looks a lot like Curiosity, but it has a different set of instruments on it. And one of the cool things it's bringing with it is actually a helicopter companion called Ingenuity. And hopefully that will be the first time we can actually fly on Mars. So yeah, it'll launch hopefully on Friday morning, and then it will land on Mars on February 18th next year. So yeah, so that's the end of my slides. And so I'm ready now to take questions.
Okay, that was fascinating. I have a few questions here. So, so you did talk about what happened with Opportunity, but have you ever done something that made the rover like tip over, fall into a crevice? I have like shades of Big Bang Theory and Howard and the Ravine. Does anything like that ever happen to you?
Nope. The closest that's ever happened was with Spirit. She was driving along in an area that looked safe, but it turns out there was like a thin crust layer. And when she drove on it, her weight actually broke through the surface and she got stuck in a sand trap. And so that's actually why she died, is she basically couldn't escape this little sand trap. But, you know, that was no one's fault. It looked fine. Everyone agreed it looked fine to drive over. But usually we're pretty safe. You know, avoid driving into sand pits, you know, don't go up to a ledge. We usually don't like the rover to go above about 20 degrees of tilt, just so we're not sliding uncontrollably. Yeah, we're pretty safe with the rover. They're pretty expensive. I don't want to have to pay the bill to replace it.
Yeah, I can definitely see that. So Linda sorry, Linda, I'm gonna pronounce this wrong. Antonishek asks, how long after you move the arm do you get to see what actually happened? What is the delay?
Yeah, so it can be as short as a couple hours, but it's usually a day or two later. So for example, I was on shift on Wednesday of this week, and the activities that I planned on Wednesday should be coming down shortly. So I don't know how the robotic arm activity went yet, but it's usually a couple hours to a day or two is the typical delay.
Okay. Tisha asks, how long does it take from conception to actual launch?
It's a good question. So typically, from coming up with the idea of, we're going to send a rover to Mars to it's on the launch pad is on the order of a couple years to a decade. I know there are some missions that have been in development. I think Perseverance was probably in development for about a decade at this point. At least the general idea, and then kind of moving on from there. So it takes a while. There's a lot of little things you have to think about to end up with Mars rover.
Okay, Linda asked, why not always use autonomous mode? What are its disadvantages?
Yeah, so the main disadvantage of the autonomous mode is that it's very slow. The computers on the rovers are not very good. And the reason for that is because they have to pick a computer well in advance of when it launched, and it has to be able to survive the radiation environment of space, the vibration of the rocket launch and landing on Mars. Like, these are very tough computers. And so they just don't have the computer capacity to really go fast. And so that's the main disadvantage. And also, you don't necessarily want to use it in areas where you don't really know what you're getting into. So we can actually image from orbit with some of the cameras there and get high resolution images, but you never quite know what rocks may be in the way. So unless you can see the terrain I'm driving on now is very benign, and the terrain I want to continue driving on in this autonomous mode matches exactly from orbit, you don't really want to continue on until you've taken a personal picture with the rover and see what's around you.
Stephen Swantek asks, how can the time lag, how can there be such a range in the time lag? You said 2 hours to a couple of days.
Yeah.
Range.
Yeah, so that essentially depends on when the Mars day and Earth day line up. So if we are planning on Earth when it's Mars night, then it may only be a few hours, because we'll usually send the plan to the rover between 9 and 11 a.m. its time. And it'll actually send back data through those orbiters a couple times a day. And one of them pretty consistently flies over between 2 and 3 p.m. in the afternoon. So you could only have those couple hours for those activities. But sometimes it may be that you decide to not do that 2 or 3 p.m. pass because you have so many things you want to do that day that you would rather wait until one of them passes over in the evening. So that's one of the time delays. It just kind of depends on when those orbiters are flying over us.
Okay. Are you part of the design crew? So you get to know your rover and about all the parts? So I guess with Perseverance going up, were you part of the design crew for that?
No. Typically the ones building the rover have real engineering degrees, unlike me pretending to be an engineer. So I worked on what's called the mission system side. And so that's developing how we're going to operate the rover. So let the real engineers build it, and then we figure out how to operate it.
Okay. And how many, so we have a question. How will you deal with Ingenuity and the winds to keep it on course?
Yeah, that's a great question. So there are certainly times of day on Mars where it's windier than others. We have an instrument suite on Curiosity that's actually a little weather station. And then Perseverance will also have its own weather station. And so one of the things that we're going to do before we fly the helicopter is basically a meteorology campaign, see when the winds pick up, what direction they're coming from, and take that into account before flying the helicopter.
Okay. So then how many drivers? I think that means how many people on your team are actually moving the rover around?
Yeah, so on a typical day, we have 2 to 3 rover drivers on shift. And the reason for that is because it takes so long to train. We essentially have one person that comes up with the plan for the day and writes the commands, and then you have someone else that has to check their work, because the rest of the operations team doesn't have that in-depth knowledge that you do about the terrain types in the rover system. So you always have to have at least one person checking them. And especially in remote operations right now, we have so many different ways of communication. So there's like 10 different chat rooms, and I'm actually usually wearing 2 headsets with 2 different microphones on 2 different meetings at the same time. So we've started having at least 3 on shift, one to just manage all those different communication modes. In total, there's only like 40 to 50 rover drivers. It's actually like a lot less than there are astronauts. So I can always kind of brag about, you know, astronauts are a dime a dozen.
You're in a more elite group.
Yep.
Okay. Okay. What kind of rocks are the most dangerous to drive over?
Yeah, so there's essentially 2 kinds of rocks that are the worst to drive over. So you are always concerned if you are driving over a rock that's bigger than the wheel. So we try to avoid driving over anything bigger than the wheel. Really, about half a wheel size, we start getting uncomfortable. So we try and avoid big rocks as much as we can. And then one thing on Curiosity is actually the wheels were essentially made too thin. They didn't think it would be a problem, but once we got to Mars, we found out it was a problem. That essentially all the small pointy rocks were ripping holes into the wheels. And so if you actually look at Curiosity's wheels, we actually do a monitoring activity every couple 100 meters of driving, where we take the arm and we do a detailed look of all the different wheels. You can actually see all the holes and tears and rips. And so there was a big campaign a couple of years ago to figure out how can we make it safer for the rover to drive over these kinds of rocks. And it's been pretty successful. Our rate of getting holes has really dropped down. So now it's just a matter of, in addition to looking for big rocks, look for pointy rocks and try and avoid those too.
Okay. Ben Brown asked, how is the power level of Curiosity's MMRTG? How many more years can it support activity? And I'm going to do a little follow-up. What is a MMRTG?
Yeah. So an MMRTG is essentially a nuclear power source inside the rover, in our case, plutonium. It's not, an active generator or whatever. Essentially, as that plutonium is decaying, it's generating heat, which then we can turn into electricity. And also some of it is kept as heat to actually keep the rover warm as well, because it's pretty cold on Mars. So Spirit and Opportunity were solar powered. So that's why we really depended upon the sun. And that's why the really bad dust storm a few years ago ended up killing Opportunity, is because it just wasn't getting enough sunlight. So Curiosity, not only is it a bigger rover, it has a lot more power intensive instruments. And so they made a decision to make it nuclear powered off this MMRTG. I think it stands for multi-emission radio thermal isotope generator or something like that. And so Perseverance also has the same thing. They actually just installed it on the rover a few days ago while it was in the rocket. So that's always an interesting thought of like somebody like tiny cramming themselves into the rocket to put it in. But Curiosity's MMRTG is doing well. I don't remember the exact number off the top of my head for what kind of energy it's giving off right now. But we should be good to go for many more years, probably I'd say 10-ish years plus at this point.
Okay, Tisha asked, when you're testing the rover and putting it through all the stress tests, do you use the actual rover or do you have a test rover?
Oh, that's a good question. So we do run some tests on the rail rover. Usually they run tests on all the different parts. So the instruments will get their own tests, the wheels will get their own tests. And as they start combining more and more systems, they'll run more integrated tests. And then they'll do some tests with the full assembly. So I actually got to see the rover drive at JPL for the very first time. It was very fun to see its first baby steps for Perseverance. And then once you launch it, obviously we don't really have the rover here to test it anymore. So we always build a test version of the rover. So the one for Spirit and Opportunity, we called Dusty. And that one actually just got donated to the Smithsonian. So if you head over to Udvar Hazy, you can actually see it in the restoration hangar. Then for Curiosity, we have another one. We call her Maggie. It's an acronym. I don't remember what it stands for. But, you know, it pretty much looks the same. The only thing that's really missing is the MMRTG in the back. Obviously, we don't want to unnecessarily expose our engineers to nuclear power, so it's just plugged into a wall instead. Not a standard power outlet, but, you know, just a very long cord so we can practice driving around. And we always build two versions of our test rovers. So one is as high fidelity as we can get. So it has the wheels and the robotic arm and all that kind of stuff. And then our next one is scaled down, usually just to the drive system. And that is because Mars has about 1/3 of the gravity of Earth. And so we make it such that it weighs here on Earth what it actually does on Mars. And we have a Mars yard at JPL where it has different terrain types that it can drive over. And that way we can actually see the kind of slip and forces that we would see here on Earth that the rover is actually going to see on Mars.
Okay. So David Booley, who was you in the video, asks, what did you study in school? And I want to just sort of add on to that question, because we do a lot of education here at the museum, and we've been thinking about, you know, girls in STEM. There's a big push to get girls more interested in STEM. So if you could talk about not just what you studied in school, but how you came to a STEM career would be really great.
Yeah. So I always was really fascinated by weather, especially, you know, watching the thunderstorms roll in. There was a period of time I lived in South Carolina and had to evacuate from a hurricane. You know, I pretty much a couple years, gosh, I think it was like 3 or 4 years old, my family moved to Texas for the first time. We were a military family, so moved quite a bit. And like within a week of us getting to Texas, our house was hit by a tornado. So, you know, weather's had a big impact on my life. I was actually struck by lightning as well on Friday, April 13th, 2007. So, you know, I took that as the final sign I should go into meteorology. And so, I don't know, I was always fascinated, but I didn't really know what to do with it. You know, do I be the TV meteorologist, Air Force weather officer, you know, hurricane hunter, tornado chaser? Like there's so many careers in meteorology. And so it wasn't until I actually did, while I was in high school, my family did the whole Disney World, Florida vacation. And we happened to be there a week of a space shuttle launch. And so my family, we all packed up in the car, drove out, pulled over on the side of the road and watched the shuttle launch. And at that point I was like, you know, oh my gosh, space is really cool. I want to do that. So I started reading a lot more about space, got a telescope. I went to the space camp in Huntsville, Alabama, a couple years in a row. And then it was time to decide what I had to do for college. And at this point I was like, do I continue doing meteorology? Like I've always known I've liked that. I still like it. Do I do something with the space thing? There's so many different things you could do. You could do astronomy, you could do engineering, you can do physics, you can do all sorts of things. So I finally decided I'll just stick with meteorology for now and I'll figure it out. So I decided to stay in Texas, and the only meteorology program really in the state of Texas is at Texas A&M. So it's like, okay, I guess that's where I'm going. So I went to like a campus visit program and I was wearing a NASA hoodie. And one of the professors said, hey, do you really like space? And I said, yeah, you know, NASA's really cool and stuff. And they said, well, you can go talk to this professor. We don't really know what he does, but it's space stuff and weather and it's cool. He wasn't there that day. So I went went home, looked him up, and he worked on missions since like Galileo, but had also worked on Pathfinder and all these other Mars missions, basically studying the weather on Mars. And it was like a light bulb went off in my head. I was like, I could study the weather on Mars, of course. So I immediately sent him an email like, oh my gosh, I'm really interested. You know, I'm starting meteorology in the fall. Can I please talk to you more about this Mars stuff? So my first week of college, I was listening in to the Mars Rover planning meetings for Spirit and Opportunity. He threw me in right away. My first summer in college was when the Phoenix Mars lander landed on Mars. It was a mission closer to the North Pole that actually was there to dig below the surface and sample the ice below the surface. And it was very successful. And that was my first summer college internship, was operating cameras on the surface of Mars. Like the landing day for it was exactly 1 year to the day from when I graduated high school. So my mom, like the NASA TV camera was like all up in my face because I'm sitting there like processing the images as they're coming down and, you know, putting them up for everyone to see for the first time. And it was a pretty surreal experience. And so I worked on them, worked on Spirit and Opportunity, worked on Phoenix, and then Curiosity started getting their team together. So I joined about a year before launch and stayed with my professor for grad school. I was like, well, if he's going to have me operate cameras on Mars, then of course I'm going to continue working for him. And so I started grad school and ended up leaving with a master's about a year after Curiosity landed. And at that point I said, hey, JPL, you know, I'm free. And so I ended up coming to JPL. And my first mission at JPL actually had nothing to do with Mars. I actually worked on the Dawn mission, which was visiting some asteroids in the main asteroid belt. And I worked on the latter half of the mission, which actually went to the dwarf planet Ceres. So it was a very different experience, but I learned a lot because I'd only dealt with Mars at that point. So I got to, you know, learn more about our solar system. And kind of get my feet in at JPL. And then as soon as I could, I came back to my Mars rovers. So I worked on Opportunity for several years before Opportunity went away. And now I started working on Perseverance, and Curiosity also took me back because I had almost finished training for rover driving on Opportunity when we lost contact. So Curiosity was like, well, we're not really that different drive-wise. Why don't you come learn from us and finish out? So that's how I became a rover driver on Curiosity. And yeah, and then working on Perseverance, helping to train people how to operate the Mars rover. And I'm also helping with the Psyche mission a little bit because it's essentially a very similar mission to Dawn. It's going to visit the asteroid Psyche. So both the spacecraft and the target are named Psyche, which can be a little confusing. And so right now they're still in the development phase. And so I'm helping them out because I had so much experience from Dawn. I can be like, hey, you know, here's what we did. Here's what was useful. Here was what was not helpful. Helping them out with, you know, getting their paperwork in order because there's tons of early reviews. So I'm helping them out there. So that's what I'm doing right now. Just kind of a little bit of asteroids, a little bit of Mars.
Sounds really fascinating. We have a lot more questions. So Steve Rosen asks, how often do you operate the rovers versus the rovers needing downtime?
Yeah, so we typically operate the rovers, or at least give them a plan of things to do every single day. We only plan typically Monday, Wednesday, Friday, but if we're in that nominal time period, we'll also plan on Tuesdays. You know, early on in the mission, we were operating every single day. But, you know, slowly we got more efficient, got better at using the tools, understanding the rover. And so we were able to go down to about 3 days a week.
Okay, Kurt asks, who will be flying the helicopter in the next mission? Is that you?
Good question. I don't know. And they're actually still figuring out who exactly is going to operate Perseverance. But the operations team is supposed to start being hired next month. So hopefully next month I'll find out if I get to work on the helicopter or not. Fingers crossed.
That sounds like a lot of fun. So I know you said you weren't part of the design team for Perseverance, but did you have any input or suggestions of ways that Perseverance could be, you know, improve upon the previous rover missions?
Yeah, so I wasn't involved in that process, but since it was essentially looking to be built as close to Curiosity as possible, they took a lot of the lessons learned from Curiosity. So as I talked about before, we had the wheel issue where the wheels were too thin, they were getting torn up. So what they actually did was they made the wheels a little bit more narrow they gave it a different tread pattern. And since they made it more narrow, they could actually make it a little bit thicker because they had to stay the same weight. So if you look at Curiosity versus Perseverance wheels, they're very different. A lot of the instruments are actually improved versions from what we have on Curiosity. So the color cameras are actually from the same company. They just now come with zoom capability that we didn't have before. The laser instrument that we have on Curiosity is also on the new Rover, but now with improved signal to noise, other capabilities it didn't have before. And then some instruments that we're sending are the first time we're ever able to send them to Mars, because now the technology has gotten good enough, the chips have gotten small enough that we're actually able to send these types of instruments to Mars in a way that we couldn't before. So it's going to be really interesting to see what comes back from Perseverance, because there's going to be a whole bunch of new data types that we've never been able to take on Mars before.
Okay, there's actually a lot of follow-up questions to the rover tipping over from a rock or falling into a ravine. In particular, if something happens where you have that kind of accident or get stuck in some way, do you just, say, okay, that's it, that's the end of the mission? Or do you have resources? Is there something you can do?
Yeah, so in our particular case, what we do to avoid those situations in the first place is we have a lot of safety checks on the rover. So we can check our heading, we can check how much we're tilted, we can make sure that we're not drawing too much current on our wheels, because if you're kind of stuck against something, it's going to try and draw more power to get over it. So we have a lot of different ways that we can prevent, driving off a cliff or, trying to smash into a rock or whatever it is. The rover would stop itself first before it got to that point. But in the case of Spirit, they spent a long time trying to get it out. They brought in outside engineers. They had a whole testing lab at JPL where engineers were working practically around the clock for months trying to come up with a plan of how exactly to get the rover out. And essentially they were really close, they think, but they basically ran out of time because the way Spirit was stuck, because she was solar powered in the winter, you always have to point those rovers towards the sun to get enough power. And since they were stuck in a way that was not favorable towards pointing the solar panels towards the sun, she basically didn't get enough power to keep her warm at night. And they're pretty sure something broke from getting too cold. So yeah, that's kind of an unfortunate accident, but we certainly try. In the case of Opportunity, there was absolutely nothing we could do. Just a dust storm happened, but we spent from June through February sending commands every single day to try and recover the rover. And at that point in February, it had started getting into the winter again, and she wasn't in a good spot. So if we hadn't heard from the rover by then, it was too late. We couldn't recover in time. So that's why we decided to stop.
Okay.
So, yeah, we just try not to get in those spots in the first place. But, we keep trying even if we do.
You have to make sure Perseverance has an arm and she can then go around and upright. Pick all those lost rovers and get them working again.
Our Opportunity team kept joking that we should change it so Perseverance can go where Opportunity is and bring a couple spare parts and fix it up.
There you go. That is exactly what needs to happen. Okay. Scott Sutherland asks, will Perseverance get its own duplicate for the Mars yard, or will Maggie just serve as a test rover for both Curiosity and Perseverance?
Yeah, good question. So they are getting their own test bed model that's being built right now. I don't know when it's supposed to be done, sometime within the next few months. Obviously, they had to finish building the real one first. But yep, it will get its own model.
And this is just a follow-up from Scott. He just wants to say he is a fellow meteorologist and he is quite envious of Jeff. So there you go. And Jeffrey Crash asks if you need insurance.
No special insurance.
For your image work, how often is the calibration target on the rover used, and what is involved in calibrating the cameras?
Yeah, that's a really good question. So on Opportunity, we actually imaged our calibration target just about every day. Um, Essentially, anytime we would take a multispectral image, so instead of we essentially have these little color wheels in front of the rover cameras, and it allows in some near infrared light and that sort of thing you normally wouldn't see with your eyes. And so we want to be able to calibrate that. So every rover has a little calibration target on it. And so we try and take pictures of it fairly often. So Curiosity has not only a little like sundial color instrument, there's actually like a color palette. Everyone that I take to see like the rover says it looks like an eyeshadow palette. Um, and that also serves for the ChemCam calibration as well for their laser instruments. We actually do shoot the rover in a very specific spot where it is okay. And then, yeah, so, we perform a lot of image calibration on the ground, but obviously sending it to Mars, lots of thermal environment, the shaking from the rocket launch and the landing and everything, we'll do a pretty thorough calibration once we hit the ground. And not only do we take pictures of those little color targets, we'll also take pictures of the sky and do sky calibrations as well. And that allows us to see, maybe where dust has fallen on the lenses, so we can subtract that out of our images as well. And we'll do that every couple dozen sols. I don't remember the exact pattern off the top of my head, but it's not uncommon.
So we have this question. Do you know Director Fukley from the Mars?
Fukley? Yeah.
Fukley, Mars Exploration Directorate. I want to expand that question a little bit. Is Perseverance coming up? Perseverance going to be, is that a U.S. mission, or is it one where we have international partners? What is the Mars Exploration Directorate? That kind of thing.
Yeah. So while it's technically a NASA mission, we certainly have a lot of international partners. So our meteorology suite tends to come from Spain. The ChemCam instrument has a lot of contributions from France. One of the instruments on Curiosity is from Russia. One of the instruments on Perseverance is from Norway, I believe. It's their first time participating in a NASA mission. They're bringing kind of a radar to be able to see under the ground beneath Perseverance. So NASA tends to be a lot of international collaboration, even in the robotic sense. Dawn is another good example of an international mission that I worked on, because even though the spacecraft was from the United States, from NASA, one of the instruments was from the Los Alamos laboratory, then one was from Italy and one was from Germany. So that was fun trying to operate. I had to make sure I finished all my work at the end of the day, so when they woke up, they could see it and work while I was sleeping. And all of our telecoms were at 8 a.m. my time, which was not fun coming right out of college, but that's how it is. We're very international, collaborative. And a lot of people at JPL as well are not from the US, or maybe the first generation from an immigrant family or something like that. It's one of the interesting things about JPL is just all the different kinds of backgrounds that people have at JPL. It's very much an interesting melting pot there.
Yes. Okay. So Curiosity takes samples and analyzes them. How is Perseverance going to look for different things than Curiosity, or do the same things in different ways? How is the science the same and different?
Yeah. So one of the interesting things by sending the same instrument on multiple missions is that you can almost cross-calibrate across the missions. So you can build on the results of the previous missions. One of the interesting types of new science that they're going to be able to do that they wanted to do on Mars for a really long time is called Raman spectroscopy. And so that's going to get us a lot more interesting information about mineralogy. I am not super into that science. I just know that every scientist that I have talked to is super excited about it. So that's not my area of expertise, so I can't give any more detail than that. But one of the really cool things that Perseverance is going to do is it's actually the first step in our Mars sample return program. And so it's actually going to take samples, drill into the rock, take samples, core them up, and put them into a canister. And once we've filled up this canister, we'll drop it on the surface for the next Mars mission to come and grab and send back to Earth.
Whenever that is.
Yeah, it won't be right away. We can only launch spacecraft to Mars every couple of years.
So someone did ask, will we ever actually get physical samples here on Earth of Mars rocks? So I guess that's the answer to that sometime in the future. I think we have 2 more questions and then we're going to have to end. Does the rover driver operate all of the mechanical instruments? In other words, would the Perseverance driver operate the drill? So
the rover drivers operate, they drive the rover and then they'll operate and place the instruments on the end of the arm. So we would place the drill, we'd operate the drill, we'll operate the brush, and then we would place the other instruments like the camera and whatever. But then there are actual camera folks, for example, that would write the command to actually take the picture, and we would just call that command. We wouldn't be the one actually like operating that specific part of it. And that's how it's been for all the rovers. Essentially, if it's like the brush or the drill, the rover drivers will operate it. But if it's like the camera or some other spectrometer, whatever it is on the end, we'll place it there, but then it's up to the actual instrument teams to figure out how to operate it from there.
Okay. Last question. Do the winds affect the rover driver plans? So are you taking wind into account when you're sending commands to the rover?
So not when we're driving or operating the arm, but if we know, for example, it's going to be particularly windy, say there's a dust storm in the area or something like that, we may take some extra precautions to try and prevent extra dust from flying into the camera lenses or something like that. But that's really about it. Unfortunately, you're on Mars, it's dusty, you're going to get dust all over you. But the wind is pretty weak. It's not going to be like the Martian where, it knocks the people over, knocks the spacecraft over, all that kind of stuff. It's pretty light wind. The surface pressure is about 8% of what it is here on Earth. So that's not a whole lot of air. The top of Mount Everest is about 30%. So, it's a very, very small amount. So it's not going to knock you over. And the rover weighs about a ton, so it's not going to knock it over either.
Okay, well, that was our last question. Everybody had fantastic questions. This is our first virtual program, so we were a little worried, but clearly we didn't have to be. We had a great audience to go with our incredible speakers. So thank you very much, Keri. That was fascinating. And I want to thank everybody for tuning in and following this and listening and participating. That was fantastic. And I just hope you'll join us. August 13th, we're going to do a program on Maryland and the suffrage movement just in time for the 100th anniversary of the adoption of the 19th Amendment. So join us for that. So bye, everyone.
Thank you.